Hello students, I am Professor Sahay. I am uploading my lab video on Signal and System EC405. We have discussed the list of the experiment which is based on the MATLAB programming. We will perform 10 experiments. Today we are going to perform the 5th experiment, which is write a program to find linear convolution of the two sequences, and we have to plot the results. We know that convolution is a mathematical process in which we take two signals and perform the mathematical convolution. So we will discuss the convolution. So in mathematics, in particular function analysis, convolution is a mathematical operation on the two functions, let it be f and g, producing a third function that is typically viewed as a modified version of one of the original functions, giving the area overlap between the two functions as a function of the amount of that one of the original function which is translated. It is similar to cross correlation, which means that we have two different signals, and when we perform the mathematical operation, that is the convolution between the two signals, then it gives the common area between the two signals. And it has wide applications which are used in probability, statistics, computer vision, image and signal processing, and various differential equation where we have to perform the convolution of the two signals. Now we have the generalization of the convolution that have the application in the field of numerical analysis and the numerical linear algebra. So the convolution of the two signals is represented by f asterisk or star g. It represents the convolution between the two signals. It is defined as the integral of the product of the two functions after one is reversed and shifted, and one remain at its own position. So the shifted signal moves along the stationary signal, and the area common between the two signals represent the convolution. Here we represent yn is the convolution of the two discrete signal, where we have taken two signals f and g, and we have represented by the mathematical function with the summation signs. We have taken the variable as k minus infinity to plus infinity, fk, g and minus k, and it is represented as the mathematical commutative property between the two variables. Now we will discuss the coding of this program. We have taken one input. We have this command. We can enter any sequence. I have taken 1 2 3 4 5. You can take any other sequence. Now first we will give the n, which represents the length of the input. Now small n, which is the variable, will start from 0 to 1 and ends to n minus 1. If we have the 5 numbers, then the sequence n will start from 0 and will move to the 4. The total length will become 5. Now we have divided the figure window into 2 row, 2 column, and we have given the 1 which represent the figure 1. And for plotting the discrete time signal, we will use the command as stem n comma x. Now we will define x label and y label, and we have given the title as first sequence, and h is the input. Now we will enter the second sequence. Now we will enter the second sequence. We have given the sequence 6, 7, 8, 9, 10. N2 is the length h. Now n will, because the length is defined by the second sequence. Now L1 second length is n2. So n will start from 0 to 1 and it will go on n2 minus 1. Now we will subplot the signal 2, 2, 2 means the second row, second column, and this second figure is named as the stem n comma h, and it will, we have labeled the x label and y label, and we have given the title second sequence. Now the y is the third signal which will perform the output of the convolution. So in MATLAB this command is already there, so we have used this convolution between the two sequence by given as x and by h. Now the length of the signal will become from 0 to 1. The first sequence is n minus 1, second sequence is n2 minus 1. The total length will become n plus n2 minus 2. Now we will plot the subplot 2 comma 2 comma. Third figure will be your convolution of the two signals, and where we have used the stem command. We have labeled the x label and y label, and we have given the title as convolution of the two sequence. After writing the whole program in the MATLAB command window, either in editor window, and debugging by using debugging command and run, the output will come in the figure window, where we have used the first figure for the plotting of first sequence, second figure represents the plotting of the second sequence, third figure represents the convolution of the two sequence. So this is your first sequence, this is your second sequence, and it represents the convolution of the two sequence. So this will end your experiment number 5.